So we've done a lot of chemistry together, and just about all of that chemistry has revolved around electrons. Atoms want to get happy. They do that by adjusting their electronic situation. So they can lose electrons, they can gain electrons, they can share electrons to make bonds with other species. Some bonds are stronger than other bonds. Chemistry is driven in great part by the relative strength and weaknesses of bonds of those sharing of electrons to get the atoms happy. And way back in the very first module, we mentioned the nucleus. And we said the nucleus contains protons and neutrons. The neutrons, really, after messing around a little bit to get the relative mass we forgot about, the protons are only there because they tell us how many electrons there are in a normal uncharged atom. However, there is an extremely important topic, subtopic of chemistry, physics, however you want to call it, in which it is the chemistry of the nucleus that is important. And that's what we're going to talk about in this little module here. We're going to forget about electrons. Electrons are absolutely meaningless for us. If we don't have a balance of electrons, we just wave our hands around and we say, well, it's getting electrons from somewhere. What we are really focused on in this module is that nucleus and how the nucleus can behave in certain types of situation. Now, it is worth just going back to that very first module and reviewing what we know about these things. Protons are subatomic particles that have a mass of 1 and a charge of +1. And of course, it is that charge of +1 that has been all important to us because that relates to the electrons with their charge of -1. And the neutrons were thoroughly worthless. Well, now protons and neutrons are just as valuable as each other, and as I said, so much more valuable than the electrons. Neutrons, of course, mass of 1, charge of 0, and again, at the possible cost of repeating myself too much, it was that 0 charge that made neutrons literally dead weight when we were considering all things to do with electrons. Now, in a given atom, the number of protons is the atomic number, equals the number of electrons. There is my vague praise mention of electrons. Pretty much going to be done with that now. And the mass of an atom, mass number, A is the number of protons, which we will use Z for the abbreviation of frequently, plus the number of neutrons, for which we will use the abbreviation N. And again, just to show you how color coordinated we are, notice that when you add together the red and the blue, you get the purple. Notice, of course, mass of the atom, nothing to do with the electrons. Now, just to put that together in symbols, A equals Z plus N. Thus, for example, if we think about this funny little symbol here, the only time we've ever really thought about isotopes, well, we haven't really thought about isotopes at all. In this course so far. We will talk more about those, of course, when we get into mass spectrometry. But anyway, this is showing you that we have an atom of carbon-14, right? Carbon, of course, the symbol that makes that little 6 there redundant, because that is the charge on the particular nucleus here. We're going to keep showing that little number a lot during this, because it is important to note what the charge on the particular species is. And of course, 14 is the mass number. So this tells us that an atom of carbon-14 has 6 protons. It's got a mass of 14. Thus, it has 8 neutrons. Okay, so that was a very fast review of the atomic structure in our first module.